Alright, so they want you to find the measurement of this angle, and this diagonal. The 20 represents this diagonal, the whole length of it. And this side is 10 and this side is 14, and this is a parallelogram. So we know that opposite sides of a parallelogram are congruent, so then this is 10. And by doing that, I can separate like the parallelogram into this part. Okay, this would be the 20, the 10, and the 14. And by doing that, I can find this angle right here. Okay, once I find that angle, that's congruent to this angle, because opposite angles are congruent. And once I know this angle, I could find this angle, because consecutive angles, like these two here in a parallelogram, are supplementary. So let me set up the equation for this angle. Okay, so here we have the setup to find this angle right here. So remember that this angle has to be the opposite of this side. So you always go, you identify the opposite side, and that's the one that goes here. It's okay to have a cosine, a negative ratio. That just tells you that the angle is obtuse, because this would be in quadrant 2 where cosine is negative. And yes, that's what we get, this angle. Now remember, these two angles are supplementary, so to get this angle right here, theta, I took 180 minus this angle, and so I get 68.2. And so now I separated the parallelogram. I took this piece here, and you have the drawing right here. That's the 10 from here, that's the 14 from here, and that's a 68.2 from here. And we're looking for D, this diagonal right here. So since I have side angle side, I use the law of cosines, and here's the setup right here. Let's just plug it into the calculator, and don't forget this is D squared right here, so you have to take the square root of both sides, and this is what you end up with. Alright, so for 30, here's the drawing right here. So I drew it a little taller just so that the length and the diagonal could be more to scale. So again, remember this diagonal is 50 and this one's 35. So notice how I cut them in half, because the diagonals of a parallelogram bisect each other. And so since this is 25 and this is 25, this is an isosceles triangle, and this angle are congruent. Okay, so my goal is to get A first, because if I know this angle, I have side, angle, side, and I can use the law of cosines. But in order to get that angle, I need this angle. Okay, and to get this angle, I need to use the fact that I have side, side, side right here. I have all three sides, and so here's the work. Cosine alpha is this over this. That's just an extra point. It's nothing. And so you get this, and you then take the inverse sine of that. Inverse cosine, and this is your angle. So this is 69.51. So you need to supplement. You need this one. So here's the work for that, and so there's the angle that you need for A. So that's this angle right here. So now I have side, angle, side. So here's the equation that will help you find A. Okay. Again, careful when you input it into your calculator. And so this is what A squared equals. Take the square root of both sides, and you get this for A. Okay. Now that you have A, I'm going to break up the parallelogram, and I'm just going to take this piece of it right here. And that's what you see right here. So this is A, 35/18. Here's B. Here's the diagonal 35. So we're looking for that angle. Once I know this angle, this one is easy to find because these are supplements of each other, because they're consecutive angles. So here's the work for theta. Again, remember, this angle has to be opposite, the side opposite has to be over here after the negative. Okay, so here's the side opposite, so you have negative 35 over here. So you work it all out, and then you take the inverse cosine of this ratio. So here's your angle, 68.75. And then to find the angle up here, you just take the supplement of this angle right here. And here's the work for that one. For number 33, I drew a triangle. I labeled the pieces that we were given. So we were given side C, side A, and angle B. I circled the measurements we need to find. So we need to find angle A, angle C, and side B. So right now, the first one I could find is side B. So I'm going to set up for that. Alright, so here's the work for side B. I'll start with that one. And so you set it up like this. Again, just be careful. Do not combine these two. This is multiplied by cosine 40. And so this is what the calculator gives you. Take the square root and you get this for side B. So the next thing we want to find is angle A. And here's the setup for that. Okay. Here's the intermediate step. And then you just take the inverse cosine of this ratio right here, and that gives you the angle. First, for angle C, we could use the law of cosines again, but since it's the last measurement that we need, it's pretty safe to use to just take the fact that these three add up to 180. So add the 40 to this angle and subtract it from 180, and you get this. So for number 36, you were given side, side, side. So again, the law of cosines is the one that you need to use. And it's recommended that you look for the biggest angle first. So in this case, it's angle B because it's opposite 13, which is the longest side. So I found B first, again setting it up like this, making sure that 13, which is the side opposite of angle B, is over here after the negative. And then plug it into a calculator. Now, this number is almost 0, right? It's very, very small. 1 divided by 1 over 54. And so that's going to be very close to 90 degrees. That makes sense because cosine of 90 is 0. So this number is very close to that. I did the same thing for A. I set it up like with the law of cosines. And I got this. And then for C, I just took these two angles, added them together right here, and subtracted that sum from 180 to get the third angle. And that's what you get right here. Okay, so here are two of the area problems. Since they gave you side, 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 you're going to use Heron's formula for area. First thing, you have to find the semi-perimeter, so you do that by adding the 3 sides and dividing by 2. So for number 39, that turns out to be 27. And then you set up the formula, S times the quantity times the difference of S minus A, S minus B, S minus C. And here are the differences right here. So you multiply the 4 numbers and you get this. Take the square root of that number and you get the answer. Now they didn't give you a unit, so you just write square units because we're talking about area. 42. Same thing, you add the 3 together, divide by 2, so you get, this time it's an odd number, so when you divide you get a decimal. So treat it the same way. Here's your S, S minus A, S minus B, S minus C. Here are your differences, these 3 right here. You multiply all 4 together, don't forget the S, and you get this inside the radical. Take the square root of that number, and here is the area. Okay, pretty straightforward. Just be careful when you subtract. Okay? For number 45, I just converted to decimal the B and the C. So you see here the 0.5 and the 0.75. Add them together, divide by 2, and so you get this as your semi-perimeter. And you set it up the same way as you did the other two. Okay? This is S minus A, S minus B, S minus C. You multiply the 4 together. And here's the product of the 4 numbers, well, part of it. I just didn't want to add all the numbers. And then take the square root, and here is your area. Alright, so for 47, someone walks 380 meters this way, then turns 80 degrees and walks this way for 240 meters. And they want you to find this distance right here. Well, since I have 2 sides, if I had that angle, then I can use side, angle, side, the law of cosines to find x. They gave you 80 here, so that means that we know this one, right? Because those are supplementary angles. So this angle in here is 100 degrees. So we set it up with the law of cosines. So here's the setup right here. Here's x squared equals 240 squared plus 380 squared minus 2 times 240 times 380 times cosine 100. So this time, instead of evaluating these two and putting the sum here, I just plugged it into the calculator exactly as I saw it, and this is what you get. And then don't forget, this is x squared, so you need to take the square root of both sides, and you get this as your answer, 483.40 meters. Okay, so for number 49, they want you to find the bearing. So in other words, they want you to find this angle, the bearing of Minneapolis from Phoenix, and the bearing of Albany from Phoenix also. So they want you to find the red angle and the green angle. In order to do that, since they gave you side, 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 I'm going to go ahead and find this angle, okay, because I can do that using the law of cosines. And I know that because this is due west, right here, I know this is parallel with the ground, and it's perpendicular to the north. So with this being perpendicular and this being parallel to the ground, then I know this is a right angle. So with that in mind, I also know that if I know this angle, this would be the supplement of that angle. And then this angle and this angle, the red one, are complementary, okay, because since this is a right triangle, then these two have to add up to 90. Okay, so I'm going to need to find theta first, then this angle, and from this angle I could find this angle. Okay, so here's a work for number 49. So first I found this angle right here by using the law of cosines, which is right here. And then inverse cosine of this ratio gives you this angle. So by knowing this angle, you have this angle because they're supplementary. They're supplements of each other. So here's the purple angle, 180 minus 149.7. So this is 30.3 right here. So by knowing that angle, you know that this one and the red one are complementary because this is a right triangle outside. So then we know that 90 minus 30.3 is 59.70. And so I just wrote it in this bearing notation right here. 59.7 degrees east of north. So that's what this one would be. And then for the other bearing, we need to know this angle and add it to this angle to get the green angle. So here you have the work for alpha, which is this little angle out in here. Okay, so here's a setup, and this is what you get. So you do inverse cosine of this ratio to get this angle. Once you have this angle, you add it to 59.7, and that gives you 72. And it's also 72.8 degrees east of north. So the area of a parallelogram is base times height. Okay, and so here we have the base, 100 meters. We need the height. Okay, so let me go ahead and draw that. So we need this measure right here, the height. Well, by drawing it right there, I've created a right triangle. So here's the hypotenuse, here's the right angle right here. Okay, so I'm going to set up, using SOHCAHTOA, that it would be sine of 70 equals h over 70. So h is 70 sine 70 degrees. So here you have h, and then you multiply by 100 because it's base times height, and here's the final answer. Don't forget meters squared. Alright, for 62, it's only asking you to identify which law you'd use and why. And 62, you have side, 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 no opposites, so then you would have to use the law of cosines. For B, it's side angle, angle. You could use the law of sines because you do have opposites. So here, the angle and its opposite side. As it turns out, this is a right triangle because these add up to 90, so you could even use SOHCAHTOA for B. Okay? But law of sines definitely for B.